Hello, welcome back to another episode of Learning 6502 Assembly the Easy Way. Today we start looking into graphics with chapter 18 of the assembly lines book. So there's low resolution graphics and high resolution graphics, and today we talk a bit about high resolution graphics. And there it is. We can see the program loaded here, typed here. You can go to my GitHub repo and just grab this code and just paste on this Paleotronic tool and save a lot of typing. And then you assemble it and then we execute it. So you see, we still have a little part at the bottom of the screen that's available. So that's because we are in graphics mode 1 rather than 2. And we see our small square shape has been painted on the middle of the screen, and we have this border that's around the screen. And color rendering on the Apple was always a bit sketchy, so although this is supposed to be white, we get different colors here. So what will happen now is, as I move the mouse, it will start drawing this shape in weird rotation. So they will look a bit like just lines, you see? But this is the shape being drawn multiple times depending on the movement of the pedals, or in this case of the mouse. It's just drawing some random stuff here. And you saw that a click of the mouse cleared the screen, but then I moved the mouse a little bit again, and we had some other lines being drawn. So this is our first example of how we can do graphics. So yeah, it's not very interesting, but you can see that with this we already know how to get into graphics mode and how to clear the screen and how to load shapes on the shape table and draw these shapes in different locations with different colors, with different rotation, with different sizes. We know how to make dots. We know how to plot lines. So actually we could accomplish a lot with just these subroutines that we just learned. There's two high resolution graphics modes in the Apple II. The first mode, you have a canvas that goes from coordinate 0.0 to coordinate 279.159. And then you have part of your screen dedicated to text. So you can basically draw up here and you still see your text cursor and you can type stuff on the bottom. And that's very useful, for instance, for text adventures where we are rendering the image up there, but we still want to show text down here, and other applications with this kind of need. And then you have the high resolution mode 2, which basically it's the entire screen. So we have some extra space, and then it goes from 0 to 279.160. Also, we can use 8 different colors. However, colors, they are a bit quirky on the Apple II, and there are certain colors that we can only use on even rows and some that we can only use on odd rows. So let's basically simplify our life and start with just black and white. And then later we're gonna check how to use other colors. So now that we know this, we should look a bit into the different Apple monitor routines that we can call from assembly. So there's a routine on address hexadecimal F3E2 called AGR. If we call this routine, we basically enter into HGR, high resolution mode 1, and HGR2 is the other mode, the one that covers the entire screen. If we call this HClear, we clear the screen all to black, so basically we clear the screen. And if we want to fill the entire screen with a color, we set a color, an H color, and then we call this a background routine, which will just paint the entire screen with that color. Then there's the H color routine, which is made to set the color that we're going to use to paint, like black, white, or any of the other colors. Then there's this routine called H position N, and what this does is it puts like our painting cursor on a given coordinate. And once it's there, we can, let's say we plot a line. The line will start on that position and is going towards another position that we set. So we basically set the origin point where we're gonna do the next painting action. So H+N puts the cursor there, but without drawing anything. And Hplot does the same, but it paints a tiny dot on that position. And if we don't know what is the current position of that cursor, we can find with hfind. It's going to put the coordinates on some well-known memory addresses. Then we have hline, which is a high resolution graphics line routine. It's going to draw a line starting where the cursor currently is, right? That we set via H+N, for instance. And it's going to draw it to another point that we set via some registers. 3 routines, shape number, draw, and xdraw, are actually related with drawing shapes. So there is this notion of a shape table. It's a bit like the concept of sprites. So what we do is we have in memory the description of a certain shape, let's say a square. Then this is another book. This is the Applesoft Basic Programming Reference Manual that kind of explains how you do that. So you start drawing your shape in a certain position. For instance, in this example, we start at the very middle of the picture or the figure. And then you say, oh, I move the cursor here without painting, and then I paint here and here and here and here and back. So I end up with a square. And this, there's a way that you can describe in memory how to move the cursor to draw a shape like this. You store this in a memory table where you have many of these shapes. You can have multiple of these shapes. So again, we are not going to delve too much in detail about this topic today. We're gonna come back in further episodes, but just trust me, if you put certain bytes in a certain memory location, you're basically describing a shape that you later can draw as many times as you want, and you can draw in different magnification. So I can make a very tiny square or a big square, and then I can control the rotation of the square. I can do all these things with my shapes. And if we follow these examples, we land on this bit pattern that then it's translated into a hexadecimal pattern. And we're gonna just use this square in our example. And as I said, later we come back to this. So the shape table actually can contain many of those shapes. And this, when we call the shape number routine, we are basically telling assembly, or in this case, the Apple monitor, which one of the shapes we want to use. If it's the first shape, the second shape, the third shape of the table, etc. And once we have set this shape number, we call a draw subroutine, and that's going to draw the shape. So the shape is going to be painted at the current cursor position, right, that we set, and it's going to be painted with the color, H color, and we are going to paint the shape that we selected via shape number. And then you have xdraw. Xdraw basically is going to do an XOR on all the pixels within the shape. So we're going to erase it. So draws it, and xdraw erases it back. So usually at this point in our videos, we would just jump straight ahead to a code demo. But before I do the code demo, I actually want to walk you through this code using the book, because this is a bit more involved than some other programs we've done in the past. So this is just a demo, and it's going to clear the screen, put in graphics mode, draw a border around the screen, and then as we move the mouse, it's going to paint squares in different rotation and magnification or sizes. And usually on the Apple II, because of course the Apple II, we would not be using the mouse, but we would be using the pedals, right? That's like the predecessors of the joysticks. but we are using an emulator. In our emulator, the mouse is going to do the role of the pedals. So let's take a look at this program. So the program is sitting on this memory location, and it's just defining the addresses of all those subroutines that we discussed previously, and also setting some memory addresses. For instance, this memory address E8, it's the address where the monitor expects to find a pointer to the shape table. So we're gonna use that later. So there's, and these are the memory addresses where you can set the rotation or the magnification of the shape that we're going to draw. So we have subroutines and we have a few of page 0 memory addresses that we need. Then our program starts here. So the entry point immediately jumps to an entry point 2, because this space here is taken not by instructions, but by the shape. So this is the shape table, only contains one shape. And if you see these numbers, for instance, 0, 0, it's the end of the table. And then you have 0, 7, 1E, 36. You see it's here, 0, 0, 0, 7, 1E, 36. So it's basically a copy of these things. So we have here our shape table with the square. Then we jump to entry 2, and entry 2 we call the subroutine AGR. We set high resolution graphics mode 1 clear in the screen, and then we set H color, and H color is going to get the value hexadecimal 3 that's coming from the X register, and 3 means white. As we can see here, there's actually more than one white, but this is the first white. Then we start drawing as the borders. So we start at position 0, 0, right? We set the Y and X registers with 0. And then we call hplot, so we put a tiny dot at the first coordinate 0, 0, and then we draw a line from there towards 0, 117. I'm sorry, I'm saying this wrong. So we're actually moving this to 279, which is hexadecimal 117, 0. So we are drawing the first border, and then we keep painting until we close a rectangle with a border around the screen. And this is the place where we set memory to point to our shape table. So the shape table, you can see it's sitting on address hexa 6003. And that's why we load in 2 bytes this 6003. And then in pointer, right? So on E8 and E9, we're gonna have the pointer to the shape table. So when you say like, oh, I want shape number 1, then the monitor knows where to find shape number 1. And then I want for now to ignore this read thing here. I'm gonna talk about this in a minute. So this has to do with reading the pedals. So forget about this now. So we initialize the shape table, and here we're gonna display the shape. So what we do here is we put the cursor on a certain position, 79, 139, which is about middle of the screen. And then we say, okay, I want to use shape number 1. And then I'm going to load the rotation of the shape. And the rotation of the shape actually is coming, it's being set here. Here. So this is basically measuring the movements that you are making with the pedal or with the mouse, and this is assigning a certain rotation value. So we're gonna get more or less random rotations as we move the mouse around the screen. Then, I mean, this thing happened just to get the rotation, and then we display the shape. And you see here that we are calling draw. This is drawing the shape. Actually, it says draw +4, and this apparently has to do with some editorial mistake, because they explain here that we should actually call the routine that's 4 bytes ahead from draw, which is sort of another draw routine, which is the correct one in this case. So we could simply have pointed straight to the right address, which is F605 up here on the draw. We could have said 05 instead of 01, but yeah, because of the book has this sort of historic mistake, they fix it here. And then this checks whether you are pushing, you have push the button of the pedal. In our case, whether you push the button of the mouse. And if you have done that, you branch to E2, and E2, it's the entry point to where we basically call HDR. So this is going to wipe the screen, clear the screen again. And in next episodes, we're going to explore more about the things you can do on the Apple II with assembly. So see you next time.